Okay, so now Simpson's rule. What are we doing with Simpson's rule?
So Simpson's rule has us take this and we take the midpoint, we take two sides and we make a parabola.
Yeah, somehow.
It's kind of a messy parabola.
It's fine.
And then we use this to approximate the area.
Okay. And I know we only talked about Simpson's formula this morning. What do you remember?
I think you do 1 times this, 1 times this, and 4 times the middle one.
Okay, that is part of it, and there's a second part.
And then times your change over 3.
Okay, very good.
So
delta x over 3 times 1 times the endpoint, 4 times the midpoint, 1 times the endpoint.
So our midpoint, actually I might need that. Don't worry. So our midpoint's 2.8. You still have that.
Yeah, so it was right. So it was lucky. So we have that 14/5.
So we have 1. So we have 4 plus 4 times 14/5, 56 fifths plus 13/6.
Yeah.
And then times 1/3.
Okay. So instead of calculating this out exactly, because that'll be a mess, do some approximations and see if we can, just using approximations, get what this is.
So we can say this is 4 plus, well, this is a little bit bigger than 11. So 11 a little bit. And then plus a little bit bigger than 2.
Alright, can you do even better? Can you get the first decimals on this, of that 11 and the 2?
Alright, so 4 plus 11.2 plus 13.2 if you want to round. Or not 13, 2.2.
2.2, yeah, because it's 2 and a 6, so which we can pretend is 2 and a 5. So yeah, so that's good.
So times 1/3, which is 17.4 over 3. So
go ahead and divide that out and just see what it is. And I'm going to put our actual exact answer into Mathematica here. The actual exact answer you get here is 2.8944.
I think something happened because this is big.
Oh, yeah. Interesting. Okay. So this is actually twice the size that we need, right?
Because we technically have 2 subintervals here. The Simpsons rule uses 2 subintervals.
Okay.
So our change is actually a half, so we have to divide by 6.
Very good.
So this is about 2.9. As you can see, it's 18 minus 0.6.
Yeah.
So 2.9.
Very good. Very good. Yeah. That was a good catch on the interval. I actually put it in as 1/6 in the thing. That's why I got the 2.89. Good. All right. Good work. Good lesson too on the interval there for Simpson's rule. But it does tell you, you know, on the off chance you run across an integral that you don't know how to do, you know, as long as that integral doesn't vary too much in the interval, you can actually use these approximation methods to get rough ideas of the answer just by hand. All right, good job, man.